Hi guys, welcome back to my channel. Today we're going to be having a look at differential equations. A differential equation is just an equation that has some sort of derivative involved. So this could be a first order derivative, so something that's been derived once, or this could be something that could have been derived twice, so a second order differential function, or 3 times, or 4 times, etc., and so on and so forth. But really what we have to do when we have a problem that has a differential in it, we need to solve the differential by finding some sort of expression y is equal to some function. So when we have a differential equation, a lot of the time what we're actually doing is integrating to solve these functions. So let's have a look at this particular function here. So dy over dx plus 12x cubed is equal to 0. So we need to solve this differential equation. So I'm just going to treat this like I would regular algebra. No difference in the rules here. So we have dy over dx is equal to negative 12 x cubed. Now when I have a derivative of this form and I want to express it in y is equal to some form, that means I'm going to take the integral of both sides with respect to x, and I'm going to have y is equal to negative 12 x to the power of 4 over 4, so y is equal to negative 3x to the power of 4. And of course, I have to add the c onto the end. So that's our first differential equation. Let's do another one. So here we have another differential equation. This one's a little bit more complex. So what we want to do first is we want to rearrange, so we have dy over dx is equal to some function. So I subtracted 1 from this side and then I divided through by 5 minus 4x squared. The next thing we're going to do is we're going to integrate each side with respect to x, and I need to make sure that I pop the little dx in there as well. To perform this integral, I'm going to let this inside function equal to u. So u is equal to 5 minus 4x. I'm going to then derive with respect to x, so the derivative is going to be equal to negative 4. So now when I rearrange, I'm going to have du over negative 4 is equal to dx. So I can replace this inside function here, and I can replace this dx on the end here. Alright, so I'm going to have two negative values here, so they will cancel out. And then what I can do is I can pop this factor out the front, so we have 1/4 of the integral of u to the power of negative 2 du. So this is a pretty straightforward integration step now. So our solution for y is negative 1 over 4 multiplied by 5, take 4x plus c. So that's how we solve some simple differential equations, and that's in particular with respect to x. So what I want to do now is I want to have a look at some differential equations that are going to be integrated now with respect to y. So this differential equation now, we only have this y variable that's involved, so we're going to have to integrate with respect to y. We also have a value of our function, so when x is equal to 0, the function is equal to 3 at that point. So let's go ahead and let's rearrange this equation so that we have dy over dx is going to be equal to 7 take away 4y. This time, since we're integrating with respect to our variable y, I'm actually going to invert these. So we have dx over dy is equal to 1 over 7 minus 4y. So now we can go ahead and we can take the integral of both sides, but now we're going to do it with respect to y. So again, with this particular integral, I'm going to let this bottom function equal to u. So u is going to be equal to 7 minus 4y. The derivative of u this time with respect to y is going to be negative 4. And when I rearrange this equation, I'm going to get du over negative 4 is equal to dy. So I can go ahead and I can substitute in my value for dy, and I can go ahead and substitute in my value for u. This is now going to be a pretty straightforward integration. So we're going to have y is equal to negative 1 over 4 ln of u plus c. And we also know that our original value of u was 7 minus 4y, so we can go ahead and pop that in. Apologies, that should have been x is equal to, because we integrated with respect to y. So I'm getting my x's and y's mixed up. Now that we have our function that we've integrated, we also have this additional piece of information. So when x is equal to 0, the value of this function y is equal to 3. So let's go ahead and substitute these values in and then solve for c. We now have our solution for c, so we can go ahead and we can pop that back in the original function. So we have x is equal to negative 1/4 ln 7 take 4y plus 0.4. Now lastly, what we should really do is we should actually express this as y is equal to something. But for this video, I really just want to show you the process of solving differential equations rather than rearranging functions. Let's just do one more example of a differential equation solving with respect to y. All right, let's go ahead and solve this last equation now. So dy over dx plus 6e to the 3y is equal to 0. And we have this additional piece of information when x is equal to 1, the value of the function y is equal to 0. So the first thing I'm going to do is I'm going to rearrange my equation so that I have dy over dx is equal to negative 6e to the power of 3y. Now, because I want to integrate this with respect to y and not with respect to x, I'm going to flip the function so that I have 1 over negative 6e to the 3y. Now that I've got it in this form, I'm going to take the integral of both sides, and this time I'm going to take that with respect to y. Now, when I do this integration this time, we're going to write x, right? Because we're integrating with respect to y, so we remove that, right? That was the mistake I made last time. Sorry about that. I'm going to pop this negative 1/6 out the front here, and I have 1 over e to the power of 3y dy. So let's go ahead and let's integrate this function. All right, so there's our equation. Now we have this additional information. We could substitute this in and find c and then rearrange. Alternatively, we could rearrange and then find c. Either way, it's not really going to make a huge difference. If I have if I have x is equal to 1, then I know y is equal to 0. So let's just go ahead and solve for c. And then we have our value for c. So let's go ahead and pop that back into our original function. So we have 1 over 18. Oh, I made that a little big, that line, didn't I? So 1 over 18 e to the 3y plus 17 over 18. And then we could go ahead and we could rearrange this and solve for y if that is what we wanted to do. Again, I just want to show you the general process of solving differential equations, so I'm not going to show you that in this video. All right, guys, so that's how we solve differential equations, both with respect to x and with respect to y. I'll see you in the next video.